Alrighty. So, we are looking at, guys, the first lesson in the last unit of Science 10. Your cheer here. Oh, good. That makes me feel good you didn't cheer. Good. Okay. So, we got to look over essentially the components of climate, and more importantly even than the components of climate are the factors that affect those components. All right. So essentially, what are the things that we would consider to be part of climate, and then what are the things on Earth that affect those things? Okay. Thirdly, the effect of climate on plants, animals, and humans. Okay. Describe energy inputs and outputs of various environments. Okay. And create and understand climatograms, which is something we'll be working on basically the rest of the week. Okay. Once we get done with that. So, in terms of inputs of energy, what's the input energy for all systems on Earth? From the sun. Solar energy is the input of energy, unless you are talking about the very small percentage of deep sea benthic environments where, okay, the initial source of energy is not from the sun. Okay, we're talking like stuff that is so far down in the ocean that sunlight simply does not penetrate. Okay, there are some ecosystems down there that thrive on volcanic energy, heat, and things like that. Cam, of course. Nope. No. Okay. So moving along here. Okay. Definition of climate. Okay. Climate is the prevailing weather conditions at a location. All right. That is what you could expect weather-wise at a certain place. Okay. It is not today's weather. That's weather. Okay. Climate is the prevailing weather, right? What is normal for a certain place? Everybody with me there? Okay. So the major components, and these are important. These are something you definitely have to know because, man, you always get asked about it. Okay. I mean, you think about it. The major components of climate are the things you want to know most about the weather. Okay. What temperature is it? Okay. Is it going to rain, snow, hail, whatever? Okay. Is it going to be sunny or cloudy? Okay. And how much sun are we going to get? Is it going to be like today where it's going to be, 7 hours or less? Okay. And that's not because it's cloudy, but because we'll only be in the sun for 7 hours today because it's December 15th. Okay. We're 6 days away from the shortest day of the year, right? Okay. And is it going to be windy? Well, the answer around here is generally yes. Okay, if you live in Lethbridge, it's always yes. Okay, because it's always windy in Lethbridge. All right. So those are the 4 major components of climate. Now, those things can be affected by a lot of factors within the environment. Okay. For example, what thing most affects all 4 of those things for us? Right. Latitude. Latitude is the single largest factor affecting climate for any place on Earth because it is the thing that determines the intensity and amount of sunshine you will receive. Okay, if a question ever asks you, what factors affect this place, the first thing you should write down, regardless of what the place is latitude, because latitude always affects your weather. Okay, the further from the equator you get, okay, the less intense the sunshine is, and we'll talk about that in a minute. All right, now, looking at this picture here that we've got, okay, taken on, summer day, it's August, something like that, maybe late July, right? What's in that picture? What kind of cloud? Someone whispered it. They were right. Cumulonimbus, okay? A cumulonimbus cloud, okay, is the type of cloud that makes a thunderstorm, all right? And a cumulonimbus cloud is a great example of all of these things working together to create a weather condition. Okay? What kind of day does it have to be, generally, to get a thunderstorm? Yeah, it's got to be warm/hot. Okay? What else does it have to be? If we're going to get rain, there has to be a lot of this in the air. Okay, no, generally there aren't a lot of clouds until this happens. Humidity. It's got to be muggy. Okay, that, you know, those kind of days where it doesn't matter how much you sweat, you just never feel cooler. Okay, so it's going to be a muggy, hot day. Generally, there's not going to be a lot of wind. Okay, until of course the storm starts, right? But generally, there's not a lot of wind going on. Okay, on a day like that, and if it's going to be hot and muggy, okay, then we've got to have fairly intense sunshine, and we said, okay, lack of wind on a day like that. That's the kind of stuff that builds a thunderstorm. All right, because to get a thunderstorm, you have to have an interaction of these factors. So early on in the day, what you have is hot air rising. Okay, so we're looking at this diagram right here. Okay, hot air is rising and it's taking with it water vapor. Okay, because it's a muggy day and hot, humid air is rising up into the atmosphere. As it goes up, it starts to do what? Cool. And when it cools, it condenses back into water droplets. Okay, so back into liquid water, and that's what builds a cloud. All right. This happens every day in the summertime. It just doesn't always make cumulonimbus clouds. Sometimes it just makes the fluffy white late day cumulus clouds. Okay, but if the weather conditions are right, okay, these water droplets, okay, will start to fall back down. Okay, but there's so much hot, heavy air moving upwards that those water droplets are buoyed back up. Okay, and they're pushed even higher, which is what causes the cumulonimbus cloud to build and get taller. Right? You guys have all seen that. I mean, sometimes you can actually see the cloud. You can, if you watch it for like 2 minutes, you can actually watch it swell. All right, it gets taller and bigger and puffier. Okay, even in a space of 2 minutes. So those water droplets can't fall down. They're pushed back up by more hot, heavy air. Okay, that hot, heavy air is bringing more water vapor up. That water vapor condenses. The cloud gets bigger. Okay, that water droplets or those water droplets try to fall, but they can't. They get pushed back up, and the whole process just grows. Okay, and you start getting this cloud that is getting bigger and bigger and bigger. Now, those water droplets, they start to get bigger as well because there's more and more of them, and they join together. Right? They try to fall back down, but they can't. Believe it or not, big drops of water can be pushed back upwards by the force of rising hot air. Right? And so what happens is they go through this cycle a whole bunch of times, and the cloud gets taller and taller and taller. Okay? Upwards of 15 or 20 kilometers. All right? Now, usually when they get to this stage, they start to get kind of flat on the top, and they get kind of shaped like an anvil. Okay, at the top. That's when you know you're really in for it. If you've got these big puffy cumulonimbus clouds and they're starting to get flat on the top, you know you're in for tornadoes, hail, okay, stuff like that. We got that big hail, okay, this summer. All right. Now, you've still got all this air trying to move up. Okay? It's trying to move up, and the water droplets are getting bigger, and they're going above the point in the atmosphere where the temperature is 0 degrees Celsius. So what do? They turn into ice. Okay? These water droplets freeze. Now the chunks of ice, they also try to fall down. But on a day like this, there's actually enough force from this hot, humid, rising air to push the cubes of ice, not cubes, balls of ice, okay, back up into the atmosphere. And as they go up, all the water vapor that was in that hot, heavy air condenses onto them and freezes onto them, making the hailstones get bigger. The more times a hailstone goes through this cycle, the bigger it gets. Okay? Most of the time they fall before they're, the size of a pea even. Okay? But in some cases, they can get really big. Okay? This summer, we had some that were like, golf ball, ping pong ball size. Okay, hail. Right? If they're really hard when they come down, they can be quite dangerous and very damaging. If they're soft, okay, luckily the ones we got this summer were generally kind of soft. They were big, but they were soft. Okay, they're less dangerous, but they represent a lot of water. Okay, and they can cause flooding if there's a lot of them. Right, so more and more of that goes through, and then near the end there, in the third picture, you can see that you get to this dissipating stage where, yeah, there's been enough cloud cover that hot, heavy air isn't rising anymore. Okay, and when that happens, it's like pulling the drain in the bathtub. Okay, literally there's just not enough air moving up anymore to hold all this stuff that it was previously pushing, and it just all comes down at once. Okay, just like pulling the plug in the bathtub, all the water just comes down. Okay, and then it all comes out. And when that happens, you also can get funnel clouds dropping out of those clouds. Okay, in an attempt to very rapidly balance the pressure differential that forms, okay, as a result of all this air movement, okay, tornadoes will do that. All right, so you've got all this air moving up, but you don't have a lot coming back down. Okay, you get a very big difference in pressure. Okay, and that difference in pressure is very quickly equalized by a funnel cloud or tornado. Okay, anyone ever been near one? Yeah, it is scary. Okay, take it from me, it is really scary to be near a tornado or funnel cloud. Okay, because you can see the cloud start to move. You can just see it start to spin. Okay, and if you are out in the middle of nowhere, you know you are really in for it because you got nowhere to hide. Okay, where should you hide? Yeah, ditches aren't bad if that's your only option. Okay, okay. Under a bridge is again okay if you don't have any other options. Okay, you can actually get sucked out from under a bridge. Okay, if the tornado goes right over top of the bridge that you are hiding under, it will suck you right out. Okay, yeah, it is really, really scary. Really heavy building, preferably not on the top floor. Okay, you want to be in the basement, cellar, okay, something like that. If you go down to like Kansas and Oklahoma and places like that, okay, they all got storm shelters, they're like tornado cellars, okay, that they can go into, right? And those kind of places are generally safe because, okay, the tornado will go over top of you and not pull you out because you're closed in, right? But underneath a bridge where you're not closed in, it can actually have enough air moving that it'll pull you right out. Okay, same with a ditch. I mean, a ditch is safer than standing upright. Okay, but if the tornado comes over top of you, it's going to pull you out. The safety of being in a ditch is you're less likely to be killed by the #1 cause of death in a tornado. Debris. Yeah. Foreign objects, okay, that are flying at high rates of speed through the air. Okay, most people that are killed in tornadoes are not killed because the tornado picks them up and throws them vast distances. They're actually killed by the stuff that's being thrown around, okay, by the tornado. You know, pieces of wood, okay, bricks, rocks, okay, things like that. Everybody with me? Now, this kind of stuff can really cause some weird things to happen. Okay, in 1 or 2 places, these types of storms have actually made it rain fish. Tornado goes over a lake, right? It goes over the lake, it draws a bunch, and it pulls up, it just happens to go over a school of fish, sucks the fish up into the funnel cloud, okay? And then the funnel cloud dissipates, and there's not enough pressure to hold the fish, boom, and it rains fish. Literally, you check, it's happened in several places where it goes over top of a water body and sucks up the fish and then deposits the fish somewhere else and rains fish. Okay? Now, what do you suppose the biggest hailstone you could get out of one of these types of storms? Okay, tennis ball are uncommon, but they happen. Baseball, softball. Okay, biggest one ever recorded. Ice cream pail. Okay, when they melted it, it had 3.5 liters of water. Yeah, if you were standing under that thing, you would be dead. Okay, it made a hole in a person's house. All right, yeah, okay? That's how they were able to capture it. It was on the living room floor. Okay, so yeah, dangerous certainly. Okay, but yeah, big stuff is uncommon. Okay, back about 12 years ago now, they had a big hailstorm in Wainwright, Alberta, and they had softball size hail. Okay, like people's windows were broken. You know, they all had to get their shingles. The whole town had to have their shingles replaced. Okay, because their roofs were terribly damaged. Every car at every car dealership, brand new, written off. Okay, their entire inventories written off. I mean, you can't repair the damage from having nature throw softball-sized hail at cars. Okay, they just don't survive that. All right, they're full of dents that you can't pull out. They're parts. Okay, all they're good for is parts. Okay, after that. So yeah, certainly. Okay, these things can contribute to very rapid, violent types of weather. All right, 4 components of climate. Okay, factors that affect climate. We said latitude is the #1 factor. Affects every place. Okay, latitude, big deal. Okay, reason for that. Your latitude, because the Earth is round, okay, affects the intensity of the sunlight you receive. if you are at the equator, the sun is directly overhead. All right? And so assuming these bars, and these bars are the same width, okay, they represent equal amounts of sunlight. Well, when this amount of sunlight hits the equator, okay, it hits an area that big. All right? It's directly overhead. It's very intense. If we go a little bit further north, okay, that amount of sunshine is now hitting a larger area. Okay, notice that my blue line does not go all the way to the bottom now. So it's the same amount of sun, but it's spread over a wider area. So is it as intense? No, which means it's not giving you as much heat. Okay, it's not giving you as much energy, and it gets worse. Further north you go, or south you go, okay, from the equator, the less intense the sunshine is. Now, this is exacerbated. This is what the Earth looks like at 2 days of the year. Okay, because only 2 days of the year is the Earth straight up and down like this. All right, on the spring equinox and the fall equinox. Okay, so March 21st and September 21st. All right, are the only 2 days of the year where the Earth looks like this. Right now, for us, the Earth is tilted away from the sun. All right, so it's even worse now, right? Not only are we not in the sun most of the time, we're in the dark, okay, because we're on the opposite, we're over here and the Earth is spinning like this now, okay? But when we actually are in the sun, we're up here. Okay, we're way up even higher, meaning the sunlight is even less intense. So we get 6 or 7 hours of it, and what we get is so puny, okay, that it's just not really doing anything. Right, we've been fortunate. We've had some atmospheric fluctuations here the last little while that have melted all the snow. Okay, we get that here, right? Because we're lucky we get Chinooks. Okay, but right, in general, we're getting a lot less sunshine, a lot less intense sunshine. Now, in the summertime, it's better because in the summertime, the Earth's tilted like this, right? Which means we're actually like down here. Not quite that much, but you get the idea. Okay, is the sun more directly overhead? Yeah, so it's far more intense. It's giving us far more light, and we're in it 18 hours a day. Okay, like on June 21st, right? It's light when you go to bed, and it's light when you wake up. Right? Everyone follow me there? All right. So latitude affects, okay, the inputs of solar radiation. The closer to the equator you are, the more intense the sunshine is, and the more regular it is as well. All right? When the Earth, flip-flops on its 23.5-degree tilt, okay, it doesn't affect people at the equator very much. All right? Their length of day changes by an hour, okay, at the most, and their intensity of sunshine changes like very little. They don't really notice it. Okay? But up where we are, we notice it a lot. Okay, second most important factor affecting your climate is your altitude. The higher up you go, the colder it gets. Simple fact. All right? I mean, if you look out the window, you can see that the mountains have snow on them. We don't have any, but the mountains do. Okay? And they tend to hold it for a lot longer as well. Okay? Do they get a little bit more snow than us? Probably. Okay? But they're also a lot higher than we are. Okay? Now, we're pretty high above sea level here in Okotoks. Okay? Here at the school, our altitude is 1,092 meters above sea level. All right, so we are over 1 kilometer higher than Vancouver. Okay, as an example. Everyone with me there? Okay, so we have pretty high altitude. And you can notice that. You can even notice the changes within town. Okay, there's lots of times where if you're driving through, the middle of town through the river valley, okay, it's warmer down there than it is up here at the school, right? Because we're probably 70 or 80 meters higher here than you are down at the river. Right? And it makes a difference. Okay? Altitude affects your temperature. On average, okay, every 1,000 meters you go up makes a difference of 6.4 degrees Celsius. Okay? So all other things being equal, okay, someone with essentially the same kind of conditions that we have, okay, but a lower altitude is going to be warmer than we are. Right? And I can tell you for a fact that this is 100% true. Okay, I took this picture, obviously a long time ago. Okay, but it was on a hike that my dad and I did, and we started out. Well, it's not in this picture because it would have been like down here. somewhere, okay, at Berg Lake Campground. Okay, this is Mount Robson, right, in BC. Okay, and we hiked up from Berg Lake, and at Berg Lake it was about 14 degrees, and it was kind of drizzling a little bit. Okay, as we got higher and higher, the temperature just kept going down, down, down. Okay, this point here is about 1,600 meters higher than the campground we started at. Okay, it was starting to like sleet on us here. Okay, so obviously it was quite a bit colder. Okay, 1,600 meters, and it was just above freezing at this point. Okay, up here on the peak. Okay, that day they got 30 centimeters of snow. Okay, they got blowing winds, and it actually blew a climbing party off. Okay, they continued to climb even though the conditions got bad, and they were blown off the mountain and killed. Okay, so yeah, you just don't do stupid things when you climb. Okay, but same place geographically, we weren't separated by more than a few kilometers. Okay, but they were up top. Okay, they were probably another, I would say another 3,000 meters above. Well, probably not 3,000. Probably another 1,500 meters above where we were. Okay, and it was snowing there, and it's snowing intensely. It was pouring rain on us. Okay, whereas down below it wasn't. It was only drizzling. Okay, difference, temperature, dew point, things like that. Okay, makes a huge difference. Okay, as you go up. Okay, temperature always goes down. Everybody follow me there? Okay. Okay, distribution of land and sea. Being next to the ocean makes a difference in your temperature, because the ocean acts as what we call a heat sink. Okay, water can absorb and hold lots and lots of thermal energy. Now, according to the second law of thermodynamics, if the air were to get colder than the water, energy would start coming out of the water and into the air. Agreed? Okay, and so the ocean regulates the temperature of the areas around it. Okay, which is why Victoria and Vancouver, okay, and all the kind of coastal cities, okay, at least especially along the west coast, tend to be more temperate than places in Alberta that have the same latitude. All right, you guys follow me there? Like right now in Vancouver, right? I mean, it's raining there, but it's warmer. It very rarely drops below freezing. Okay, in Vancouver or Victoria, because they're so close to the ocean, and the ocean can regulate their temperature. Now, if you go to the east coast, not as much of an effect. Yes, they're next to the ocean, but the ocean is not so much shallow, but it's colder. Okay, the Atlantic Ocean there is in much closer contact to the Arctic Ocean and to big sheets of ice like by Greenland and things like that. And the ocean currents that go by Newfoundland are coming from the north, whereas the ones that go by Victoria and Vancouver are coming almost out of the southwest. So they're bringing warmer water, whereas the ones next to Newfoundland are bringing cold water down. So they tend to freeze, okay, more quickly. Well, if there's a sheet of ice over top of the water, is that whole transfer of energy working as good? No, you've got a kind of a barrier there. Okay, so you don't notice it as much in those kind of conditions. So you can see here, okay, the currents that are coming up past Victoria, okay, and Vancouver are coming like from, the south, well, the Pacific Ocean for sure, okay, kind of South Pacific-ish, bringing warm water, okay, whereas here by Labrador, look where those currents are coming from, okay, they're all coming out of the north, out of the Arctic Ocean, okay, bringing much, much colder water. Okay, so does everyone follow me there? Okay, so yeah, distribution of land and sea. So if I was to ask you a question on a test and say, tell me what factors would most affect the climate of Victoria, okay, you would say latitude, because you'd say that for no matter what city I would say, okay, and tell me why. It's kind of far from the equator, whatever. Okay, would altitude be a factor? What altitude is Vancouver at compared to us? Low. As low as you can be, really. It's at sea level. Okay, I mean, there's a few places on Earth that you can stand on that are lower than sea level, but okay, not very many, right? Because generally, if you're below sea level, you're also underwater. Okay, so altitude would certainly be a factor there. It's much lower, and being close to the ocean. Okay, being close to the ocean can regulate your temperature because of the second law of thermodynamics. Energy flows from the ocean into the air if the air temperature drops below the ocean temperature. We don't get that here. Okay? We don't have any big bodies of water around here that can absorb lots of energy and then transfer it into the air when it gets cold. That's why we can get massive fluctuations in temperature. We've seen that happen, right? It goes from being, like it is today, where it's, going to be around 0, and then a day later it's minus 35. Okay? That just doesn't happen in Vancouver. Okay? They'll get some fluctuations, but not like that. Okay? I mean, we've had days where we have like a 40-degree fluctuation in temperature. Okay? It can happen, but it doesn't happen near the ocean. Okay, and then nature of ocean currents, that's what we just talked about here. Where is your water coming from? Well, okay, you look at certain places and they might be affected more by, Gulf Stream type stuff, coming up from southern areas where, okay, the water's a bit warmer. Now, special ocean currents that happen once in a while. Okay, you've probably heard of El Nino, right? Okay, some people are saying we're getting one this year. Okay, they tend to be kind of cyclic, 4 to 7 years. Okay, the El Nino is a upwelling of warm water off the coast of Chile, okay, down in South America. Right? It is such a large upwelling that it can actually change worldwide temperatures by a couple of degrees. Okay? Now that doesn't seem like very much, but when you think about how much water and air that involves, it's a lot of energy. Okay? And so it can change ocean temperatures by a few degrees and air temperatures by a few degrees worldwide over the course of several months. Okay? So that can make us have a very mild winter. Okay? On the other side of that, when El Nino stops, okay, then there's a massive fluctuation, and then we get his evil sister, La Nina. Okay? And yeah, that's generally bad. We get one of those really cold winters where everybody's locked in the deep freeze for 6 months. Okay? Happens on occasion. Okay, here's one that affects us big time. Distribution of mountain barriers. Okay, we're right next to the Rockies. Okay, we get what? That you don't get anywhere else. Chinooks. Okay, if you talk to somebody from somewhere other than Alberta and you say the word Chinook, they look at you and go, "What is that, an Eskimo word?" Okay, they have no idea what it is because they don't get them. Okay, it is a highly localized phenomena. Okay, because we live here, we know what it is. Okay, we love them, they're good, they make the snow go away, they make it warm, right? But other places, they don't know what that means. Okay, it's just not something they experience in other places. Just here, the conditions are right for it. Right? What happens is the mountains will cause air that's warm and moist coming from BC to go up, and as it goes up, it condenses, it cools, and it deposits all of the rain and snow on what we call the windward side of the mountains. Okay, which is why places like Hope, BC, if you've ever driven the Coquihalla Highway, right, they've got the big snow sheds and avalanche walls and stuff like that because they get so much of this happening there. They're the ones that catch all the precipitation. Okay, as that air gets up and over the mountains, it's lost all of its moisture. Okay, and it's dropped in temperature. As it starts to come down the other side, okay, there's some friction against the mountainsides. You get some heating from the sun and things like that, okay, and you get what's called like a katabatic effect, and it starts rolling down the mountain, picking up speed and heat. Right? It heats up and it comes rolling off the mountains as a warm, dry wind. Okay, that's where Chinook comes from. But what it also causes is what we call a rain shadow. Okay, so this is what we call the leeward side of the mountains. Okay, and on the leeward side of the mountains, you get rain shadows. Okay, in some places, rain shadows are prairies, like they are for us. In other places, they're deserts. Okay, if you go to Asia, behind the Himalayas is the Gobi Desert. Okay, the Gobi Desert is extremely dry, and it's not very warm either. Okay, it's kind of a cool desert, right? But it's caused by the fact that not very much moisture gets over the Himalayas. They're very, very tall. Okay, and they get rid of most of the precipitation before they get over. Okay, does that sort of make sense? All right, probably going to have to end it there today. What do you need to bring for tomorrow? Pencils, calculator. Make sure you have those things, all right?
Why do some people get migraines?
Migraines can be caused by pressure. So when you get a wind or a Chinook and things like that, it affects your middle ear. Right, the wind can blow in your ears, and that can give people really bad headaches. Lethbridge has the highest incidence of migraine headaches of like basically anywhere. Yeah, it's massive pressure changes, right?